Good morning everyone. Today we are going to discuss few more problems on determinant, properties of determinant and very important rule, the CRAMER'S rule. Let us move on to this episode.
First question, if capital A is equal to 1, 1 minus 2, 2, 1 minus 3, 5, 4 minus 9, find determinant A. If you want to find the determinant of the given matrix, the matrix has to be a square matrix. Yes, the given matrix is a square matrix of order 3, 3 by 3. Square matrix in the sense, number of rows is equal to number of columns. Yes, 3 rows are there, 3 columns are there. So the given matrix is a square matrix of order 3. Now we can find the determinant of the given matrix. Determinant A is equal to determinant 1, 1 minus 2, 2, 1 minus 3, 5, 4 minus 9. How to find determinant of 3 by 3 matrix? Expanding with respect to first row, alternative plus minus. Expanding with respect to first row, alternative plus minus. That is 1 into plus minus plus 1 into. Including this element, I have to eliminate this row and I have to eliminate this column. Remaining elements 1 minus 3, 4 minus 9. So 1 minus 3, 4 minus 9. Minus 1 into 2 minus 3, 5 minus 10. 2 minus 3, 5 minus 9. Now plus minus 2 into last element. Including this element, I have to eliminate this column and I have to eliminate this row. 2, 1, 5, 4. 2, 1, 5, 4. This or no? 2, 1, 5, 4. What is the remaining element? 1 into. Minus 9 into 1, minus 9, minus 4 into minus 3, minus 12, so minus into minus is plus, so plus 12. This or no? Now, minus 1 into, minus 9 into 2, minus 18, minus 5 into 3, 15, minus is there, so minus into minus will become plus, so 15. This or no? Plus into minus is what? Minus 2 into, 4 2s are 8, 8 minus 5. So that is 1 into 12 minus 9 is 3 minus 1 into 15 minus 18 minus 3 minus 2 into 8 minus 5 is 3. Listen here, 3 minus into minus is positive, 1 into 3 is 3, so 3 plus 3 minus 6. So 3 2s are 6. 3, now 3 plus 3, 6 minus 6. Second question. Find the value of x if determinant 3x1 is equal to 3, 2, 4, 1. We have to find the value of x. Listen, the given matrix is of 2 by 2 matrix, that means square matrix, so that I can find the value of determinant. Listen, so that is first one. Determinant 3x1 is equal to determinant 3, 2, 4, 1. 3 ones are 3 minus x into x square is equal to 3 minus 8. 3 ones are 3, 4 twos are 8. 3 minus x square is equal to 3 minus 8 is minus 5. Now minus x square is equal to variable I am keeping one side, numbers I am taking to other side, that is minus 5 minus 3. Yes sir, plus 3, that's why we go minus 3. So minus x square is equal to minus 8. Minus minus will be cancelled. So x square is equal to 8. Therefore x is equal to root 8. This root 8 can be written as root of 4 into 2. So no? This root 4 I have plus or minus 2. That is x is equal to plus or minus 2 root 2. This is the right answer. So no? This 4 root 4 is nothing but plus or, this can be written as root 4 into root 2. This 4 is nothing but what? Plus or minus 2 to root 2. Plus or minus 2. The value of x is equal to plus or minus 2 root 2. Is it clear? Go through that. Now, second one is 2, 1. Listen here. 2 ones are 2 minus 5 4s are 20 is equal to 2x into x, 2x square minus 6 4s are 24. So 2 minus 20 minus 18 is equal to 2x square minus 24. Now 2x square is equal to minus 18 plus 24. That means 2x square is equal to 24 minus 18 is nothing but 6. Therefore x square is equal to 6 by 2. That is x square is equal to 3. Therefore value of x is equal to plus or minus root 3. Is it clear? Go through this. Very important type. This one. Very important concept. Properties of determinant. There are total 6 properties are there. Today we are going to discuss only 4 properties. 4 important properties we are going to discuss with example. First property. If we interchange the rows and the columns in the determinant of order n, then the value of determinant remains unchanged. That means interchanging the rows and the columns, that means the concept of transpose. Yes or no? If I have one matrix 1, 2, 3, 4 and I am going to find the value of this determinant, that is 4 minus 6, answer is what? Minus 2. If I am taking the transpose of the given matrix, what is the transpose of the given matrix? 1, 2, 3, 4. What is the determinant? 4 minus 6. What is the answer? Minus 2. Both are same. Both are same. That's what this property tells. If we interchange the rows and the columns in the determinant of order n, then the value of determinant remains unchanged. That means if you are taking the transpose of the given matrix, the value of determinant will not change. That means if you have a square matrix capital A and if you are finding the determinant A for the given matrix, you will have an answer, name it as K. Then after taking transpose of the given matrix, again if you are finding the determinant A transpose, the answer will be the same. Answer will be the same. That means if you are interchange the rows and the columns in the determinant of order n, the value will not change. Is it clear? That is nothing but the first property. Second property, if any 2 rows or columns, if any 2 rows or columns of a determinant are interchanged, then the sign of determinant changes. Then the sign of determinant changes. Listen here, I have 1, 2, 3, 4. If any 2 rows or columns of a determinant are interchanged, and what is the answer for this? 4 minus 6 is what? Minus 2. Yes or no? 4 minus 6 minus 2. I am going to interchange this row. That means first row I am writing 3, 4 and second row I am writing 1, 2. What is the answer? 6 minus 4. What is the answer? 2. That means the sign changes or not? Here minus 2, here is 2. That's what they are telling. If any 2 rows or columns of a determinant are interchanged, then the value of the determinant sign will change. Value of the determinant sign will change. Sign of determinant changes. So first I have matrix 1, 2, 3, 4. I am finding one value that is minus 2. I am interchanging this row. First row I am writing as second row element and second row I am writing first row element. That means interchanging R1 and R2. That is 3, 4, 1, 2. You will get 6 minus 4, that is 2. Here it is positive number, here it is negative number, that means sign only changes. Is it clear? Now third property, if any 2 rows or columns, are identical, then the value of determinant is 0. Then the value of determinant is 0. That means if you are saying 2 rows are same or 2 columns are same, that means the entries or the elements are same. If 2 rows are same elements or 2 columns having same elements, then the determinant value is 0. 1, 2. First row is 1, 2. Second row is also 1, 2 means 2 ones are 2 minus 1 2s are 2 minus 2 is 0. Like this. Then one more example. 1, 5. Again, one more column, 1, 5. Both are same. 5 minus 5 is 0. So here 2 rows are same, here 2 columns are same. Yes or no? These type of matrix, this type of determinant is property is the third property. So if any two rows or columns are identical, if any two rows or columns are identical, then the value of determinant is 0. Very important property, third one. Now fourth one, if each element of a row or column, if each element of a row or column of a determinant is multiplied by a constant k, then its value gets multiplied by k. For example, listen. Capital A is equal to 4, 2, 3, 5, which is square matrix of order 2 by 2. So I am going to find the determinant A. Listen here carefully. Determinant A is nothing but determinant 4, 2, 3, 5. That is 5 4s are 20 minus 3 2s are 6. So 20 minus 6 is nothing but 40. So determinant A is nothing but 40. So now what they are telling, if each element of a row or column of a determinant, each element of a row or column, so I am going to select first a row of a determinant is multiplied by a constant k. So here I am going to choose the value of k is nothing but 2. Value of k, that constant is nothing but 2. Then its value gets multiplied by k. Listen, value is multiplied by k. So first I am going to select first row of the matrix. I am going to multiply it with the value k. Here the value of k is nothing but 2. So you will get a matrix capital A after multiplying with the 2 on the first row. That is 2 4s are 8, 2 2s are 4, then remaining as it is. Remaining as it is. So that is, now find the value of determinant. So determinant A 4, 3, 5. What is the determinant value? 5 8s are 40 minus 4 3s are 12. 40 minus 12 is nothing but 28. Yes or no? That means if each element of a row or column of a determinant is multiplied by a constant k, then its value gets multiplied by k. Then its values gets multiplied by k. That means if I am multiplied with the k value, you will get the same answer or not? That means what is the value of k over here? 2. I am multiplied with respect to what? First row element in the first matrix. That means 14 into the value of k is equal to, that is 28 or not. That's what this property tells us. Is it clear? If each element of a row or column of a determinant is multiplied by a constant value k, then its value gets multiplied by k. Then the value gets multiplied by k. So here I have selected only row. Better try for column. Try for column. Listen here. Cramer's rule. This was introduced by Gabriel Cramer in 1750. Let us discuss what he has implemented in this theory. Let us consider a1x plus system of linear equations I am going to consider. a1x plus b1y plus c1z is equal to d1. a2x plus b2y plus c2z is equal to d2. Now a3x plus b3y plus c3z is equal to d2. All these variables, all this constant a1, b1, c1, a2, b2, c2, a3, b3, c3, d1, d2, d3 are belongs to real numbers. Then, if you want to find the unknown variable x, y, z, so here we have three unknown variables, that is x, y, z. Gabriel Cramer has introduced how to find the value of x using determinant is x is equal to delta x divided by delta and y is equal to delta y divided by delta and z is equal to delta z by delta. This delta is nothing but taking the coefficient of, taking the determinant of coefficient of unknown variable. Coefficient of unknown variable. So here the coefficient of unknown variable is something but x, y, z. So a1, b1, c1, a2, b2, c2, a3, b3, c3. Which is we have to take the determinant. That means you will get the square matrix of order 3. So how to find delta x, delta y, delta z? This delta x, delta y, delta z you will understand while I am doing the problems, while I am doing the example. I have an example. So that is 2x 3x plus y is equal to 4. 3x plus 2y is equal to 2. Listen here. 3x plus 2y is equal to 2. Here the coefficient of x and y for the first equation is 2 and 1. And the coefficient of x and y for the second equation is 3 and 2. Right hand side in place of d1 and d2 I have 4 and 2. Is it clear? So first I am going to find the value of delta, because delta is having for all the unknown variable we want to find the delta. So first I am going to find the delta. What is delta? Taking determinant of the coefficient of unknown variable. Taking determinant of coefficient of unknown variable. Coefficient of unknown variable, that is 2, 1, 3, 2. Yes or no? 2 2s are 4. 4 minus 3 is nothing but 1. So the value of determinant is nothing but 1. Now delta x, you want to find the value of delta x in the sense that is also a determinant. First column of the delta. This first column is nothing but the coefficient of x or not. So in first column, if you want to find the value of delta x, you have to replace that x coefficients by d1 and d2. That is 4, 2 you have to write. Remaining as it is 1. So find this. 4 2s are 8 minus 2 1s are 2. 8 minus 2 is nothing but 6. Is it clear? So delta x is nothing but determinant of coefficient of x I have to replace by d1 and d2. Coefficient of x I have to replace by d1 d2. I have replaced by d1 d2. Yes or no? Similarly, what is delta y? Delta y is equal to determinant. Coefficient of y I have to replace with the d1 d2. That means first column 2 3. Coefficient of y I have to replace with the d1 d2. That is 4 2. Yes or no? So 2 2s are 4 minus 4 3s are 12. 4 minus 12 is nothing but minus 8. Minus 8. So the value of x is equal to delta x by delta and y is equal to delta y by delta. What is delta x? 6 by 1. Answer is 6. Now minus 8 by 1. Minus 8 by 1 is nothing but minus 8. So the value of x is nothing but 6 and the value of y is nothing but minus 8. This is nothing but a Cramer's rule. Very very important. For 2 by 2 matrix you can find. For 3 by 3 matrix also the same thing. One question is there. That is x minus y plus z is equal to 4. 2x plus y minus 3z is equal to 0. X plus y plus z is equal to 2. So second question. System of linear equations. X minus y plus z is equal to 4. 2x plus y minus 3z is equal to 0. X plus y plus z is equal to 2. So coefficient of delta is nothing but coefficient of unknown variable. That is 1 minus 1 1 2 1 minus 3. Look at the equation. 1 1 1. First find the value of determinant. Determinant of 3 by 3 matrix. How you have to find out? Expanding with respect to first row, alternating plus minus. Alternating plus minus. That is 1 into including this row, I have to eliminate 1 minus 3 1 1 minus 1 into. Again, replace 2 minus 3 1 1 plus 1 into plus 1 into 2 1 1 1 2 1 1. So we get 1 into 1 ones are 1 minus 1 into minus 3 minus 3. Yes or no? Plus 1 into 2 ones are 2 minus 3 plus 1 into 1 2s are 2 minus 1. So that is 1. 1 plus 3 is 4. So 4 plus 3 plus 2 5 5 ones are 5 plus 2 minus 1 is 1 1 ones are 1. 5 plus 4 9 plus 1 10. So determinant value is nothing but 10. Now we want to find the value of delta x, delta y and delta z. See, delta x is equal to same determinant only. In place of x coefficient. In place of x coefficient, I have to replace with the right hand side. So 4, 0, 2 remaining as it is. Minus 1, 1, 1, 1, minus 3, 1. We can find the value of delta x. Now, delta y, how I have to find out? In place of coefficient of y, in second column, I have to replace with the right hand side d1, d2, d3. So first I am writing 4, 0, 2. Remaining as it is. 1, 2, 1, 1, minus 3, 1. How to find delta z? Delta z is equal to last column. That means in place of coefficient of z, I have to replace with the right hand side d1, d2, d3. So here 4, 0, 2 remaining as it is. 1, minus 1, 2, 1, 1. This is the way you have to find out delta x, delta y, delta z. After finding delta x, delta y, delta z, you can find the value of x, y, z. X is equal to delta x by delta, y is equal to delta y by delta, and z is equal to delta z by delta. This is the way. What's the value of delta? Delta you have 10. Delta x, you can find the value of determinant for 3 by 3 matrix, expanding with the first row, alternative plus minus. Let's try this problem. Is it clear? This is nothing but a Cramer's rule. Was introduced by Gabriel Cramer in 1750. Is it clear? Okay. So far in this episode we have discussed 2-3 problems on determinants, properties of determinant and Cramer's rule. It's a very important rule. I suggest to practice the problems, then only you will get to know the idea of delta x, delta y, delta z, how to find. If anyone did not subscribe my channel, please do subscribe and press the bell button. Thank you. We'll see you in the next episode.